today we're going to continue looking at the first section, so chapter 1, section 1, but it's the second part. So two operations we talked about yesterday for solving equations. Can someone remind me again, what were those two properties we used? Two different operations to solve equations, yeah?
Addition and subtraction.
Yeah, we used addition and subtraction. Okay, you don't have to write this part down. The first thing you're going to write down is when I talk about a coefficient. Okay, so that's just a review from yesterday. Okay, so today, the two operations we're going to look at are multiplication and division. Now, when we divide, we talked about this when we did the survival guide. There's a certain number you have to be careful about. We don't want to ever divide by this number. Yeah?
0.
0. Okay, we never want to divide by 0. So when you do the addition and subtraction to solve an equation, you can add and subtract anything you want from both sides. But when you multiply and divide, you can almost do anything you want. There's only one number you can't use, and that's 0. Okay. So we'll talk more about that as we solve some equations. All right. This part, again, I just want you guys to watch this part. When we did the addition property of equality, it said that you can add the same number to both sides of an equation. When we did the subtraction property, it said you could subtract the same number from both sides. What do you think the multiplication property says? Yeah?
You have to multiply on both sides.
Right. The multiplication property says you can multiply both sides of an equation by the same number, and you'll end up with an equation equivalent to what you started with. That's the key. Anytime you solve equations, you have to end up with something equivalent. Because if you do something that messes up what you have from what the original problem was, now you're going to get the wrong answer. So we are allowed to multiply both sides of an equation by any number we want except the number 0. Okay. All right, so now on your guided notes, the first line you guys have says, if the coefficient of a variable is a fraction. Okay, so when would that happen? Well, that would look something like this. If we had to solve an equation like that, we've got a fraction in front of the letter. That's what the coefficient is. To solve a problem like that, after the word fraction, you're going to write down multiply each side of the equation by the reciprocal of the fraction. And we're going to practice a little bit now with fractions and then finding the reciprocal. If you have a number in front of a variable and it's a fraction, we're going to multiply each side of the equation by the reciprocal. All right, so we'll try that, but first let's just make sure we know how to find reciprocal. So right below that, you guys have a little table in your guided notes. Okay, we have a fraction side, and then reciprocal side. So on the left, I'm going to give you a number, and on the right, I want you to find the reciprocal. Okay, let's do the first one together, and then I'll let you guys try the other ones. So 5 over 2. What would be the reciprocal of 5 over 2? Sam?
2 over 5.
2 over 5. So we just take what's in the top, put it in the bottom, what's in the bottom, and you put it in the top. Any question on that? All right, so let me give you guys a few more to try. So the next one is -3/4. The one after that is 2 divided by a. And the one after that is b divided by c. Okay, so whether you have letters or numbers, it doesn't matter. You still find the reciprocal the same way. Okay, so take a minute or so and see if you can find the reciprocal. And we'll come around and check what you did. Alright, so let's take a look and see if we can find the reciprocals of these other numbers. How about Madeline, what'd you get for the reciprocal for negative 3/4?
Negative 4/3.
Yep, negative 4/3. Perfect. So it started out as a negative number. When you flip it, it's still negative. You just change what's in the top and the bottom. Okay, how about, Evelyn, what'd you get for the reciprocal of 2 divided by a?
A divided by 2.
Yep, it's going to be a divided by 2. Very good. And the last one, Zach, what'd you get for the reciprocal of b divided by c? Yeah.
I didn't get that one.
You get to that one? Anybody get to that one? b divided by c, Lily?
C over
C over b. Okay. So c over b. Perfect. Okay. Any question on that? So that's what a reciprocal is, but then we have to use it to do something. We're going to use it to multiply both sides of the equation when we solve it. Now, usually when there's a number in front of a letter, we use division. But when there's a fraction, we have to do it this way. Well, we don't have to, but it makes it easier. Okay. So let's try. You know what? Let's write down the steps first, and then we'll try some examples. So under that first bullet, you're going to write down, find the number with the variable attached to it. The number could be a fraction. Okay, it could be a fraction. If the number that's attached to the variable is a fraction, and this is what we just wrote down, you're going to multiply both sides of the equation by the reciprocal of the fraction. Okay, so that's like one case you could have today. Multiply both sides by the reciprocal of the fraction. Now, it might not always be a reciprocal. Okay, so reciprocal, it would look like this. 2/3 x equals 20. That's the type of problem that you would multiply both sides by the reciprocal. But what if you had like a division, like a letter, and then you divided by a number? So if you have a letter that's divided by a number, you're going to multiply both sides by the number. What would that look like? Just put it right up here. X divided by 5 equals 6. X divided by 5 equals 6 is a problem where you have a variable divided by a number. In this case, divided by the number 5. We're not going to solve that one right now. But if you were going to solve it, you would multiply both sides by what number in this case? 5. Yep. You'd multiply both sides by the number 5. So that's another type of problem you'll see today. And here's the third type you'll see. If you have a number or even a number with a decimal attached to a variable, like 4x equals 50. Okay, that's not a fraction attached to the variable. That's not a variable divided by a number. it's a variable times a number. It's got a number attached to it. If you have an equation that looks like this, then we're going to divide both sides by whatever's attached to the variable. In this type of problem, the 4 is what's attached to the variable, so you would divide both sides by the 4. But that's pretty much the 3 kinds of problems we're going to look at today. Now, once you do, for whatever kind of problem you have, once you do that step, then you're going to have something to simplify. So like in this last one, if you divided both sides by 4, now you're going to use your calculator and do it up. What is 50 divided by 4? We have to finish that up. So that's where you're going to simplify. And you can use your calculator if you need to. And the last thing we always do, well, we do it if they ask us to, is we check our answer. As I told you, we're not going to necessarily check every single problem we do all year, but at first, just to practice a little bit, we'll check some of them. Okay, so once you write that in, that should fill your guided notes in right up to the examples below. You should have the 3 round bullets filled out, and then the 3 like greater than signs filled out as well. Give people a second to copy that. And then we'll do example 1A. Your example 1A is off to the right of all the stuff you just wrote down. Mine, on the screen, I could fit it below it, so that's where I put it. Okay. Does anyone need a little bit more time to copy down anything that's up there? All right, so you guys should have a spot for example 1A, but do you have the example written in yet? Okay, so let me give you guys that. And the first thing I just want to do is kind of identify which one of these it is. Let's consider this like case 1, case 2, case 3, just to make it easier to talk about. X divided by 4 equals -7. Which case is that one?
1.
If a fraction is attached to the variable, so that means you think it looks like this one?
Oh, no.
Having a number next to the variable? That's a fraction? Anyone see which one it looks most similar to? And you got your 3 examples right here to go by.
2.
Yeah, that's most similar to case 2, where you have a letter divided by a number. And what does it say to do in case 2 to solve it?
Multiply both sides by 100.
Right, multiply both sides by whatever the number is. So in this case, what's the number that we divided by?
4.
4. Okay, so take a second and see if you can solve that. And then I'll come around and check your answer. Yep, and then see what you get for the answer. Okay, so we said that this one is case 2. And the directions in case 2 say that if you have a letter divided by a number, we have to use the opposite operation. So we see division. The opposite operation is multiplication. And we're going to multiply both sides by the number that we divided by. So we're going to put multiply, multiply. And what number are we going to multiply both sides by?
4.
4. And 4. So now, what happens on the left if you do 4 times x and then divide by 4? Yeah.
Is it just like X?
Yeah, it's just x. If you take something and you times it by 4 and then divide it by 4, you just canceled out what you did. It's kind of like if I took a number and added 3 and then subtracted 3. It just goes back to what it was, it cancels out. So, timesing x by 4 and then dividing x by 4, those cancel out. So what do we have on the left-hand side now?
X.
Just x. Now on the right-hand side, we have to simplify what we have. So we have a negative 7 times a positive 4.
Negative 28.
That's a negative because it's a negative times a positive.
And then 28.
And then 7 times 4 gives us negative 28. Okay, so we solved it. And then what else did they ask us to do?
Check.
Yeah, they asked us to check it. So let's do that off to the side. And can someone remind me, how do we check if negative 28 is the right answer?
Log in 28 into X.
Plug in what for x?
28. Negative 28. The negative 28.
The negative 28. So we're going to take and copy down the original problem. Except instead of having an x, we're going to put in the number that we think is the answer, negative 28. And again, I usually put the question mark there because that's what I'm trying to see, is that right? Well, let's check it on the calculator. So we take negative 28 and divide by 4. I get negative 7. So negative 7 equals negative 7. Is that true? Does negative 7 equal negative 7?
Yeah.
Yeah. What would happen if it didn't work is you might have like negative 7 equals 4. Okay, you'd get different numbers on each side, and that means either you checked it wrong or your answer is wrong. Question on that? Let's try 1B. Okay, so let me put the cases back up. Which case does this one look like? 1, 2, or 3? Yep.
1.
Yeah, that's case 1. It says if a fraction is attached to a variable, multiply both sides by the reciprocal. Well, before we can multiply, the first thing we have to figure out is what's the reciprocal? Yeah. So we're going to have multiply and multiply. And what's the number that I'm looking at? And then I have to figure out the reciprocal.
2/3.
I'm looking at the number 2/3. What's the reciprocal of 2/3?
3/2.
3/2. And we're going to multiply by 3/2 on both sides. Now, one thing I like to do, I mentioned it earlier, if I use fractions in a problem, I like everything to be a fraction. So there's only one thing here that's not a fraction, and that's the what?
The 6.
The 6. So how can we make that a fraction?
Put a 1 under it. Yeah.
Yep, put a 1 under it. So that's the first step. Multiply each side by 3/2. And now see if you can simplify the left side and the right side. So when you're done, you should have y equals, and then tell me what you get. Okay, so try that, and we'll check what you. So here, we're multiplying 3/2 and 2/3. Whenever you multiply fractions and you have the same number in the top and the bottom, you can cancel it out. And then we have a 2 in the top and a 2 in the bottom. That's the whole reason why we multiply by the reciprocal. It cancels everything out on that side. If you didn't do it that way, and you say, all right, I'm just going to multiply straight across, which you could do. What's 3 times 2? 6. And then in the bottom, 2 times 3. 6. Well, now 6 divided by 6 cancels out. So I think it's easier to cancel the numbers out, in this case, first, while they're smaller, rather than when they're bigger. Okay, but they're going to cancel out either way. And all you have left now on the left side is a y. So we got y equals. And now the right side, you can do either way. You can multiply the way it is and then reduce. Or reduce first. Let's just multiply the way it is because the numbers aren't that big. Okay. When you multiply fractions, you go straight across. Okay. I saw just a couple people did things like on a diagonal. We'll talk about that. That's more when you have what's called a proportion, which we're not really doing yet. So just go straight across. All right. 6 times 3. How about, Evelyn, what does that give you?
18.
Yep. 18 over. And now in the bottom, 1 times 2. Yeah? 2. So you get y equals 18 divided by 2. Now, if it was like 17 divided by 2, I would say just leave it, because 2 doesn't go into 17. But 2 does go into 18. What do you get if you divide 18 by 2, right?
9.
9. Okay, so there we go. You get y equals 9. All right, now, did this one say, yeah, on here, guys, it said to check it. So let's check this one. So we're going to take and fill what number back in for y?
9.
9. So we're going to have 2/3 times 9. And the question is, if you do 2/3 times 9, do you get 6? That was the original problem. Right there. 2/3 y equals 6. Okay, so on my calculator, I think you can type it in just like I'm going to do. No, they have a fraction button on the calculators I use. I don't have a fraction button on here. So I just have to type it in like this. That's how you type in 2/3 on this calculator. 2/3 times 9 gives me 6. So I get 6 on the left. I get 6 on the right. Does that mean my answer worked?
Yep. Nope.
Yep. Why not?
Do you check it?
I did. I checked it.
Okay, okay.
Yeah.
That's what I said.
So yeah, we checked it and we got the same number on both sides. So we're good.
Okay.
Yep. So it worked. If you get like 6 equals 4, then no good. It's got to be the same number on both sides. Okay. Any question on that one? That was 1B. All right. So we did the type where you have a letter divided by a number. You've got a fraction attached to a letter. So now, both of those problems we multiplied. Multiplied by the reciprocal. Multiplied both sides by 4. What's the last operation we're going to look at that we can use to solve equations? We did the addition, subtraction, multiplication. Yep, division. So that's the last property. So the division property of equality, again, just like the other properties, you guys can just look at this part. The addition property says you can add the same number to both sides. Subtraction property says you can subtract the same number from both sides. Multiplication property says you can multiply both sides by the same number. What do you think the division property says?
Divide both sides.
You can divide both sides by the same number. Yep. There's only one number you can't use though. And you can't use 0. So you can divide both sides of an equation by the same number, any number you want, except 0. And that won't mess anything up. You'll get an equivalent equation, which means hopefully it's simpler than what you started with, and you can get the variable by itself. let's look at this one. So example 2A. 18 equals 3x. I'm going to go back to the cases, and I want to see if we can figure out which case this one looks like. 18 equals 3x. Okay, does that look most similar to case 1, 2, or 3? Yeah, 3. Yeah. I know the variable's on a different side, but you have a whole number attached to a letter, and it equals a number. So when we have a whole number attached, what operation do we use on both sides? We're going to use division. All right. So why don't you guys take a minute and see if you can solve that one, and then we'll go over it. Okay, so we said that this one was the case where we had a whole number attached. So what operation did you use?
I divided.
Okay.
3 by 3, and that cancels out. And I divided 3 by 18, and I got
You divided what on this side?
3.
You divided 3 by 18?
No, 18 divided by 3.
Okay. So yeah, I did 18 divided by 3.
And then I got 6.
Yep. So on this side, these cancel out. Now they don't cancel out because it's 0. What's 3 divided by 3? 1. So that cancels out because you have a 1. And now all you have on that side is 1x. Or we normally just write x. And then on this side, 18 divided by 3 was 6. Okay, I'm going to hold off on checking that one. I think that's good. So x equals 6. Any question on that one? Okay. So let's take a look. Do I have an example 2B? I know I have about the word of. Oh, there it is. Okay, so try that one. If you get stuck because you need a calculator, that's okay. Just go as far as you can until you would need a calculator, and then we will go over it.
When you show the operation stuff for you?
Oh, the different cases?
Yeah.
Yep. So, and there's your different cases. And same thing you should have on your guided notes. So let me put the problem back up. And see if you can solve it. So what operation are we going to use to solve this one?
Division.
Yep, we're going to divide. And we're going to divide each side by 8.5.
That's how it cancels out.
Because what's 8.5 divided by 8.5?
1.
1, not 0. So it cancels out because we get 1.
And then 40 divided by 8.5 is 4.70, repeating.
Is it exactly 4.7 and then it just keeps going 0 forever?
No, it's 4.7058 repeating.
Okay, so then if we're going to round it to 2 decimal places, how would this properly round to 2 decimal places? To 2. What would you get if you round that to 2?
You get 5. 4.71.
4.71. Yes. So that's 4.705. If we're going to round to 2, that digit is a 5 or higher, it rounds up.
If it's 5 or higher, you round up, and if it's not, you just do that.
Right. So if we're going to round it off, we would put x, we'd put 4.71. Now, Was it exactly 4.71?
No.
No. So the symbol we usually use for that looks like that. So it's kind of a wavy equal sign, which means it's about 4.71, but it's not exact. Now, what if I wanted to round to 1 decimal place? What would the answer be? Yep.
4.7.
Yep, 4.7. And let me put the answer back up. What if I wanted to round to 3 decimal places?
7.706.
6. Yep. To 3 decimal places, it'd be 4.70. That next number is higher than a 5, so it would be 706. Yep. I would say most of the time we don't round to 3 decimal places. 1 or 2 is about what we do. Any question on that? All right. So, if I said to you, I want to find half of 10. Let me just write that down. Half of 10. Well, what number in math means half? How do you write it? 0.5, or as a fraction? You could write 1 over 2. And if I wanted to do of, what do you think that means in math? So let's try it. If we do 1/2 divided by 10, so there's 1/2 divided by 10. Is that number half of 10? 0.05?
No.
No. What number are we trying to get?
5.
We're trying to get 5. So what can you do with those to get 5?
Multiply.
You can multiply. So the word of, okay, on your guided notes, means multiply. The word of, frequently we use that to mean multiply. Any question on that? Alright, so last thing. Do you guys already have that all printed on your, is it the same number, 19.32? Yep.
Yeah.
Okay. So this one, you would have to know a formula to do it, and I'm going to give you what that formula is. All right? It's the formula that connects 3 things: distance, speed, and time. And the formula starts out looking like this. Does anybody know what the formula is that connects distance, speed, and time? So, and it starts out D equals,
I know the equation I just
Is it like D equals B times C?
well, it is multiplication. On this side, we usually use T
Oh.
for time, and we use R for the rate of speed. D equals RT. So you might not have known that, but did anybody know that now that I showed you the formula? Okay. So this is the formula that connects distance. I should write that down. This is distance. This is your speed. And the last one is your time. So what we have to do is look at our problem and fill in whatever we can. So it says in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. We're solving for how fast did he run on average. Obviously, he started from standing still, and then after a while, he got up to his top speed. But what we're doing is just finding his average speed. Okay. Let's go from left to right, looking at what we know and what we want to find. Do we know the distance in this problem?
Yes.
What is the distance?
200 meters.
So this is going to be your distance. So you're going to fill in what number for D?
200 meters.
200. Do we know the speed?
No.
No, that's the question. Solve an equation to find the speed. Since we don't know the speed, what are we going to leave it as for now?
R.
We're going to leave it as r times. And do we know the time?
Yes.
What's the time?
19.32.
Yep. Very good. 19.32 seconds. Now, this is a case where I don't think using the dot for multiplication is going to be the best because you're going to have a number next to it with a decimal. So to me, if I write something like this, I don't know, it kind of looks a little confusing.
Make the dot bigger.
But yeah, I can make the dot bigger, or if I just put parentheses, I think that looks very clear now that it's multiplication. Okay, so we did the first part, write an equation. Now the second part is solve it. How are we going to get r by itself here? We're going to multiply or divide?
Divide.
We're going to divide. And what are we going to divide by?
19.32.
19.32. On the right side, what's 19.32 divided by itself? 1. So we cross that out. What's on the right side now? What's the only thing that's left?
R.
Just the r. So r is the rate of speed. And now we definitely need a calculator to figure that out.
10.35.
1.668.
Okay, so they didn't tell us where to round to. So, oh, they did. You're right. The nearest hundredth. Thank you. So they did tell us. The nearest hundredth. How many decimal places is that?
3.
That'd be thousands.
2.
2. Hundredth is 2. Thousandths is 3. So what's his speed to 2 decimal places properly rounded? 10.35. The next number is a 1, so the 5 stays the same. So the speed is 10.35. And what was the length that we used to measure distance in this problem?
Meters.
So 10.35 meters per, what was the unit we used for time?
Seconds.
Seconds. In the US, we usually use like miles per hour. Well, this is probably a European measurement, so they use meters. Yeah, instead of seconds. Well, I shouldn't say European. It's actually pretty much every country except the US uses meters. We use feet and inches. All right. So that formula, that is something you might need. Distance equals rate times time. And now you have it. Okay, so homework tonight is on Schoology, just like last night. So go to 1.1 part 2, click on the homework. Just remember, I need to see your work. Okay, if you only have answers, I'll give you half credit, but I don't know how you got those answers. So either do your work on a separate piece, or do it right on homework.